Good morning. Now we start our revised syllabus for chapter 7. We are revised syllabus chapter 7 Gujarat Board reduce some syllabus for exam. Here example number 1. Do the points 3, 2, minus 2, minus 3 and 2, 3 form a triangle? If so, name the type of triangle formed. First we know here distance formula. Form a triangle. Which condition is required to make triangle? Sum of two sides is greater than of third side. Measure of third side. And type of triangle, we use Pythagoras. If it is equal, then it is right angle. Greater than is obtuse angle, and less than it will. First we show here. Let point A 3, 2, B minus 2, minus 3 and C 2, 3. Here we use distance formula x1 minus x2 whole square plus y1 minus y2 whole square. AB square is equal to and distance of AB is equal to under root x1 minus x2 square plus y1 minus y2 square. Here AB is equal to under root x1 minus x2 3 minus 2 square plus y1 minus y2 3 minus 3 square is equal to, we find here 3 plus minus 2 then plus 2. 3 plus 2 5 square. 5 square is equal to 25 plus 2 plus 3 5. 5 square is equal to 25 is equal to root 50 is equal to, what is the value of root 50 approximately? Suppose we write here AB is equal to root 50. Root 50 is equal to 7.07 approximately. You complete here root 50, not necessary 7.707. BC is equal to, take here B and C minus 2 whole square plus x1 minus x2. Then for minus 2 whole square plus minus 3 whole square equals to minus 2 minus 4 square 60 plus minus 3 minus 6 square is equal to 36 is equal to 52. Root 52. Here root 52 is equal to, I know, 7.21 approximately. But here you complete it like this. And AC square. Therefore AC is equal to 3 x1 minus x2. Here x1 y1 and it is calculated as x2 y2. 3 minus 2 whole square plus 2 minus 3 whole square. 3 minus 2 then 1. 1 square is equal to 1 plus 2 minus 3 is equal to minus 1 square is 1. We know root 3 is equals to 1.73. Root 2 is equals to 1.8. It is form a triangle? Yes. Sum of two sides is greater than third side. 7.07 plus 1.41, that means greater than 7.21. These two are greater than 7.07 and these two are greater than 1.41. Do the points, then we write here points A, B and C form a triangle ABC because sum of two sides is greater than third side. If so, name the types of triangle. We find here AB square is equals to AB is equals to root 50. Therefore, AB square is equals to 50. BC is equals to root 52 implies BC square is equals to 52 and AC is equals to root 2. Therefore, AC square is equals to 2. Therefore, AB square plus AC square is equals to 50 plus 2 is equals to 52. With number square, it is BC square is equals to BC square. AB square plus AC square is equals to BC square. So, triangle ABC is right angle triangle with angle is right angle. AB square plus AC square is equals to BC square. This is a hypotenuse. Therefore, converse of Pythagoras, angle A is right angle with angle A is equals to 90 degrees. Here our question 1 is completed. Example number 2. Show that points are vertices of a square. Points, which points are? 1, 7, 4, 2, minus 1, and minus 4, 4. I forgot like these points here. Let point A 1, 7, B 4, 2, C minus 1, and D is equal to minus 4, 4. Show that points are vertices of a square. We know the properties of square. About sides, yes, all sides are equal. Then we find here AB, BC, CD and DA. Distance formula, using distance formula. About diagonals, diagonals are equal. Yes, AC square, suppose we find here AC square is equals to BD square. AB is equals to under root 1 minus 4 whole square plus 7 minus 2 whole square is equals to 1 minus 4 minus 3 square 9 plus 7 minus 2 5 square 25 is equals to under root 34. It is not necessary to take your here square root, value of square root. BC is equal to 4 minus 1 whole square plus 2 minus 1 whole square equals to 4 minus 1. 4 plus 1, 5. 5 square, 25 plus 2 minus 1. 2 plus 1, 3. 3 square, 9 is equal to root 34. We find here two sides AB, BC. Now find CD. CD is equal to minus 1 minus 4 square plus minus 1 minus 4 square equals to minus 1 minus 4, that was plus 4, minus 1 plus 4, 3. 3 square is equal to 9, and minus 1 minus 4 minus 5 square, 25 is equal to root 34, and find AD is equal to 1 minus 4 square plus 7 minus 4 whole square. 1 minus 4 plus 1 minus 4, that means plus 4. 1 plus 4 is equal to 5 square. 5 square is equal to 25 plus 7 minus 4. 7 minus 4 is equal to 3. 3 square is equal to 9. Is equal to root 34. We find here all sides AB, BC, CD, DN. Adding root 34, all are equal. Now we find its diagonals. AC is equal to 1 minus 1 square plus 7 minus 1 square is equal to 1 minus 1. 1 plus 1, 2 square is equal to 4 plus 7 plus 1, 8 square, 64 is equal to root 68. Now we find AD is equal to under root 1 minus 4 square plus 7 minus 4 whole square equals to 1 plus 4, 5. 5 square, 25. 7 minus 4, 80. Now, it's so wrong. BD, we find here AC and BD. BD is its diagonal. We find here AC and BD. 4 minus 4 square. BD 4 minus 4 square plus 2 minus 4 square. Yes, 4 minus 4 plus 4, 4 plus 4, 8 square is equal to 64 plus 2 minus 4 minus 2. Minus 2 square is equal to 4. 64 plus 4 root 68. Now, all sides are equal and its diagonals are also equal. Therefore, it is a point vertices of a square. Here, AB is equal to BC is equal to CD is equal to AD is equal to root 34 and which are sides of So, the points are vertices of square. Now, example 1 and 2 complete here. Number 2, points are the vertices of square. Then we find here its sides and diagonals. If its sides are equal and diagonals are equal, then it is a vertices of square.